All right. Morning out there. How are we doing this morning? Or whenever it is. All right. Oh, okie dokie. Let's see what we got going on here today. All right. How do I go back to navigate my way back around here? Bring up the notes for a second here, and let's see. Let's see. Notes. Okay, so that's and how do I get rid of? Minimize this. And let me see if I can open this chat window up here. Okay. I'll just type in welcome. And let's see. So how we doing all right out there? I should say welcome to the first meeting of John Swain's Vegas Golden Knights fan club. Oh, I couldn't resist. Sorry. Are you gonna let that go without giving me harassing me?
Doesn't half the team have COVID right now?
I think so. Like half of sports has it or something. I think, I don't know, but yeah, I think they're a little bit down for the count right now. So that means it's our chance to try out. Maybe not.
Yeah, that ended poorly. with stretchers.
Yeah, a one-game salary, might be nice, but right, I don't know if I want it. I'd have to have the year salary if I'm going to be in a stretcher. I mean, one game would not be enough. So, okay, looks like, that's told you about whatever was going on with the classes and stuff. It's not really going to end up affecting us. I had to just double check with that, but we're still good to go as normal. So obviously you're probably affected if you had any face-to-face classes. I'm sure that's obviously shut down and whatever else might have affected you. But it looks like this doesn't really change much. I didn't know if they were going to try to say that, no, I think as long as I wasn't, well, they didn't say anything, but I just want to make sure as long as I wasn't making people show up for this, we were okay. And but I think we were okay anyway. So welcome aboard. I guess if you have any questions or anything that you want to ask about, or if it's anything that's like problem, homework related, let's save that for the end. And then I don't mind sticking around afterwards and asking those kind of questions, but I just thought I'd see if there's any other general, anything I'll answer at the end also, but any kind of homework, I'll be happy to, I've been known to stick around and do that afterwards for people. So anyway, let's go ahead and so last week we did the 2-1 and 2-2, and we'll do for sure 2-3, 2-4, and we'll get into chapter 3. Also, these beginning sections are pretty short. And also we don't have an intro to go through today either. So we can start right from beginning here. Visualizing categorical variables. Categorical, once again, is qualitative data. So that they're using the terms categorical and numerical, which numerical still means quantitative and categorical is qualitative. So now we're going to look at best ways to display data that's in category form here. Now we have what's called a bar chart. Now this is, we looked at histogram. This is a little bit different. That bar chart, when it's titled a bar chart, is generally used to represent qualitative data. It's just that the difference is one of your axes will not be numerical. And I'll show you that when we get down here. And these also can be expressed in the numerical values or percentages, being the same kind of thing. It would still, the display would still look the same. Now let's see. So suppose, of course, you know, we'd have to limit this so it doesn't get ridiculous, but obviously there's more than these 5, you know, manufacturers of vehicles, but just for simplicity or whatever. So if you got like a, you know, Ford F-150 truck or, you know, or something, I'm sorry that you're not represented here, but so let's say just out of these 5 manufacturers I made up, and I made up a mythical survey here, but let's just say that these were the responses of which one is their favorite. So like I said, it's just totally made up. Of course, the main thing though is that if I say there's 200, my numbers better add up to 200. That's important. And I've used this example quite a few times, so I know it's okay. Anyway, so those are the 5 results. I won't read those out. You can see those right there. We are on share screen, aren't we?
Yes.
Yeah, okay. I don't see the green bar around my computer edge. I was a little nervous there, but because every once in a while, we're not looking at whatever you're saying there. And I said, okay, I just wanted to double check for my own insecurity there. So that's good. All right. And come down here. And then we list them out in this chart form. Now this is a little bit different than, you know, using, especially when we did the histograms for the group data where we're creating those class widths and those intervals. There's no order that these have to be done in, certainly not mathematically. Now, if you know, you want to say, oh, I got to list these in alphabetical order or something, that's fine. But there's absolutely nothing wrong with listing these the way that I did, because it's not a numerical continuation of these values because they're categorical data. But, you know, if you felt like, whatever, if you want to do alphabetical, you could. If not, you don't. As long as I have the right number, the frequency right next to the right value, I'm good. And then so you can have frequency, and then you can have relative frequency, meaning just expressed as a decimal or percentage, just each number divided by the total. Now, one thing we won't have on these kind of distributions is we won't have cumulative frequency. Because if you think about it, cumulative makes no sense in this context, because cumulative means less than or equal to, you know, a certain value. It's everything in that interval plus the one that below. Well, there's really wouldn't make much sense to say less than or equal to Toyota. In other words, that doesn't really make any sense, because that's more of a cumulative as a mathematical term. So we won't have cumulatives here, but you can absolutely have relative, meaning what is each particular value's percentages. So in other words, for example, 26% of the people surveyed picked Toyota as their favorite. Okay. Now this is, I can type this in and do it in Excel, or maybe we'll have a homework problem, but I mean, I don't, like I said, most of you could probably do it better than I can anyway. I didn't go through anything fancy and trying to change any of the colors or anything like that. I guess I could do it real quick, but yeah, you just type in the values and you can make it display. Yeah, that's one thing different about these versus the histograms. Histograms are always vertical. This could be sideways, horizontal. No problem. Like I was saying earlier, though, you see whichever way, you know, one of the axes is going to be horizontal and one's numerical, and one will be categorical. So whether it's like this way, you know, the y-axis has the labels, or this way, the x-axis has the labels, and you get a nice visual representation. And what is, oh, this is just the same thing, displayed percentage. Okay. Now the thing about whether it's percentage or decimal, you're still going to get the same basic shape of the graph. You'd be able to see, you know, which one sticks out the most. So if you look, like whether it's the one on the left or the one on the right, whichever one, I'll look at just the one on the right. You see it's kind of, it's the same shape as the one on the right above it. It's just the values on the axis are expressed as percentages. So that's just a matter of choosing whichever way you want to do it. I guess I don't know if this what comes up in the homework here, but I guess I could do this one, or I could just make up a new one. That might be more exciting. Oh, what was it? Oh, I was only changing that one cell. Oh, I meant to zoom in. Okay, sorry. All right, so I'm going to make up something and we'll just pick the graph thing real quick. All right, what do I want to be? Let's see. I'll put the frequency here and I'll figure out what I want to make up. Why is that not at the bottom of this? I really messed that up, didn't I? I'm copying, cutting this and putting it in the second cell here. Or just delete that row. All right. Okay, so, oh, I got a good one here. It doesn't really, obviously I'm just making this up. We just need some labels. Favorite hockey team. And it doesn't really matter since I'm going to let the graph do it, so I don't have to worry about adding up to a certain number here. So we're going to say, I don't worry about, I can see what they are. Golden Knights, 137. The Montreal Canadiens, 72. Let's see. I'll keep a Texas team in here. Stars, not starts. 53. And a couple more here. Let's see. LA Kings, 27. And New York Rangers, 1. Now, well, actually, we won't see the 1 very well on the graph. Sorry, John. I want to make it 10 here, though, because that way 1 wouldn't really show up very well. So, all right. Let's see. Data, insert. Charts. Oh, that was actually already got it sequential lowest to high. Okay, that's good. That's already got it done that way, highest to lowest. Maybe it's different. I remember when I did that other one, obviously it didn't. It just did it whatever way it was presented. But now it, oh, actually I did decrease the numbers. No wonder. Okay, never mind. What am I saying? I did decrease each one of them. So, I'll pick that one. So, and then you can play around, obviously, with how you want to label it. But there, that gives you the bar graph of that. So, wasn't that exciting? Like I said, most of you are probably better than this than me. So there's no point in doing that same one unless you want to do it for fun. So now here's just a couple other specific types of bar charts here. One's called a clustered bar chart, and then we have a stacked bar chart. Clusters, when you want to group side by side within the same category in a vertical direction, and stacked is when you got a single column, the same category in a vertical direction. So we'll show you, like this one shows, this is 2011, 2012 in the NFC North Division, points scored by the teams in that division. Now you come down here. So suppose that somebody then wanted to compare the 2 years side by side by each team. That's a clustered bar chart. So you see the blue is the 2011 and the orange is 2012. Now the stacked bar chart goal is it wants to show the 2 seasons combined for each team. So it's one bar so it kind of represents the 2 colors, then added together if you want to look at what their 2-year running total was as individual teams versus their team's individual total for 2 separate years. Okay, I don't know. I never really put that on an exam or anything, but I thought it was kind of neat to look at. So just your basic bar chart can have some different variety to it if for some reason someone wanted to show it that particular way. All right. let's see, pie chart, donut chart. The donut chart I haven't seen in a long time. This book talked about it, but I don't really ever use the donut chart that much, but what the heck, the pie is more commonly used one, but some people might use the donut with a little hole in the middle. But most people are pretty familiar, with what pie charts are. But that's okay if you're not. That's all right. We're going to talk about it. It just sort of takes shows the actual percentage, like you could get from the data that was in a bar graph. You get the percentage, then it just shows up, of course, the entire circle being 100%, and then you just take a wedge in there. And it shows what chunk it takes up. Of course, modern day, we'd obviously, do the same thing with, in fact, I'll go back to my other example with the hockey there, and I'll show you, we'll do a pie chart for that one. Donut looks like it just eats it up without the center hole there, right? Somebody ate the donut hole. But pie charts, yeah, super simple with Excel. Back in the old days, we did pie charts using something called a compass and a protractor, and not compass in the sense of a compass that finds, magnetic north or whatever. A lot of times I do this face to face. Even the younger students act like they know what the compass still is. I'm not surprised. It's the thing that you use that you can make circles with. And then a protractor measures angles. Yeah, why not? Let's see. Now I want to bring it up here. Compass and protractor. So no, we're not going to sit around in class and, well, if we were, we wouldn't be doing these, but look at that. Doesn't look like fun? So you make the circle, and then what you do is you use the protractor to measure, because the idea is, you have your percentage. A circle, you don't have to remember your geometry there, but it has 360 degrees in a circle. So what you do is you'd multiply your percentage as a decimal times the circle, times 360, to tell you what angle it would take out of the circle, and you would measure out your angle and make our little pie chart that way. And we even had colored pencils back then, so we could make them. We could shade them different colors if we wanted to. So, okay, there's your history lesson for today. But obviously now you can do it in about 2 seconds in Excel. You just lose the hands-on fun of doing it that way. But it's certainly a lot slower. Okay, here's that same car problem. Okay, I'll skip over all this. I just want to bring all the data right back in again, so we don't have to scroll back up the top of the page. And then you just let Excel. Now, I'm no expert on getting this set up right in Excel, but obviously, whatever it defaults, you can go in there and probably, make it show what you want it to show. And sometimes it's not so easy to figure out or whatever. Like, I'll just do this might not be a default. I might have edited this one. I don't know. But let me go back and I'll do it for the hockey one that I have on that spreadsheet right here. So I go in here and I go insert, and there's the sort of the family of the pie charts there. There's donut. If we want to see donut, you can make them even look three-dimensional pies. Ooh, exciting, huh? I'll just do a regular pie. But so you see this one. Yeah, so I don't know what I did to get all those labels in there, but it's just something to do with, formatting it properly in Excel, which, since I don't know how to do it very, very well, I'm not going to waste your time trying to figure it out. It does show other stuff. Let's see. Okay, there's that way where it shows the percentages. So I don't know how of course, some of these would be hard to get. Yeah, that 3% one would be hard to get a label. It'd be kind of pointless to get the label in there. So you can pick whichever one you like. This one's not too bad. Kind of like that one. And then you see the key across the top shows you what percentage represents what there. So how about that? All right. So All right, so that's not too bad. That's easy enough. Now this is interesting because these next couple of questions, because that's one of the big things about these charts and stuff is, you know, can you interpret these things to answer just kind of basic questions, not too complicated. But that's kind of stuff, you know, that you'll see on an exam. You won't have to actually construct well, I mean, unless I say which one of these is the right graph, but you could probably figure it out even without actually constructing the whole graph if you just calculated the percentages, you know, by each one. You wouldn't have to necessarily sketch it. But now suppose that you had, all you're looking at is this graph right here. You have the percentages and the labels, and then you were told that we had, say, there were 600 responses that created this pie graph. About how many people chose Porsche as their favorite? Now, I said about how many, depending, you'll see, you may have to round to the nearest decimal. You won't have to for these numbers or whatever, but I'll show you. I got one coming up where you would just round because the answer is decimal, and obviously the answer's got to be a whole number. So if we had 600, then how many people chose Porsche as their favorite? Does that sound complicated? Actually, it's not complicated at all. You're basically solving a little mathematical equation here that says x divided by 600 equals 0.15. So it's the same thing as saying 600 times 0.15, and that one actually came out to be exactly 90. So it would have been 90 people chose Porsche. So all you have to do to answer this kind of question as it pops up on a test is, you know, just take your grand total and then just multiply it by the appropriate percentage. Of course, keep in mind some of the answer choices might be for other percentages or whatever. So you got to pay careful attention that you pick the right percentage. You'd hate to, suppose you took the 600 and you multiplied it by the Mercedes percentage. That might be one of the answer choices, but if it's asking Porsche, that would not be the right answer choice. So that's not too difficult. Here's another one. I guess I should change this. This course used to be Stat 3309. One of these days I'll actually remember to change it, but that is this class now. So now I did one on purpose because notice I said 477 students, that wouldn't come out to be a nice smooth decimal. And there's probably a way to format this, but I'm not going to dig into it and waste your time, but there's probably a way that you can get these pie charts to show those percentages with, couple decimal places in them or something if you wanted to show it that way. I'm sure it can be done. Well, I hate to say I better not say the word sure, but it's likely it can be done. So about how many were business majors? So we got, in this chart, there's the purple's the business. So 31%. So you just take 477, the total that we were given, and then multiply it by 31. It comes up to be 147.87. So you just use normal rounding here and just round to the next whole. You can round up or down or whatever. So we would say there were probably most likely 148 business majors in that sample. Are we having fun so far? Nothing in the chat, okay. A Pareto chart contains both bars and lines, and businesses can use these to sort of identify and these are problem areas, in a business. I'm going to show you a couple examples of these. I think this might come up in the homework, but I don't put this on the exam, but we'll see if that comes up somewhere when we take a look at the homework in a little bit. But then I'll sort of show you how that line's constructed. But it's all, now this one is put, they just intentionally put these in decreasing order for it to be a Pareto chart. Remember I told you earlier that these bar graphs can really be in any order, and they can just in general theory, but this one, for the idea of the Pareto chart, they want it to be in decreasing order. So they're showing, what is this, late arrivals, I guess, to work by reported cause. Okay, so you see, I'm not going to read all those out, but, and then we've got, these are percentages up here on the y-axis. So let me show you how this line, the line always finishes 100%. Well, this is a cumulative. That line is basically, I know we don't have cumulative normally in qualitative data, but I guess maybe cumulative is not the right idea. It's just, it's a sum of whatever the categories are. But since they're specifically in decreasing order, I guess it's okay to kind of treat it as cumulative. Anyway, so the first dot goes at the upper right corner. Now the next dot, now just what you imagine here is, imagine that this child care, actually I'm just making a rough, suppose that was stacked. Suppose you create a stacked bar, traffic plus child care, that gave it the height. Well, then that's where this dot then represents the right corner of this right here, if it's stacked on top of the one next to it. I'm not sure if I'm saying that the best way or not, but hopefully out of whatever I'm babbling about here, that you're making sense out of what I'm saying. So like the next one, public transportation. Let's lift that. If you took that height, stacked it like so, and then that's this dot, which, you know, they're like that. So it's the height with each of them being stacked right to left on top of each other. And it just keeps going along like that. And then naturally it finishes at 100%, because by the time you're done, every one of them has been included. So all of them, so it's at 100%. Hopefully, like I said, it's not supposed to be that complicated, but hopefully I didn't make it sound too complicated. Like I said, I think you just got to look at these on the homework and then you'll be okay. I did not put this on an exam, but we'll take a look. Here's one. So here's one with a clothing store seeing a steady decline in business. Now this is kind of, actually, especially, I don't think you have to worry about this part right here, but this is a more advanced kind of way to do it, where you put these little 80% lines in there and you're looking to see, maybe that's your measure line of where you're most concerned about or whatever. So dissatisfaction with clothing we're selling here. But like I said, you definitely don't have, not only do you have to not worry about a regular Pareto chart on a test, you don't have to worry about these. Now, I'm not sure if this stuff's even going to be in the homework or not. We'll see when we get there, but hopefully it's not. But I guess the 80%, they're considering the top 20% to be the most significant, I guess. I don't know. Anyway, although it seems like it would be more concerned, obviously, with the higher percentages. Well, I guess it just, some things are a little bit different. Parking difficulties, maybe, yeah, that's kind of a completely different issue than, you know, you're making the clothes and that sort of thing or whatever. But so what do we got here? Difficult parking, sales rep was rude, poor lighting, layout confusing. Here we go. We get into the ones that were smaller issues, but size is limited, clothing faded, clothing shrank. So yeah, these are the more significant ones here, the 80%. That's what they're saying. I don't know why they're saying significant. Few. I think they could just leave it as significant. I don't know, but whatever. But wording seems weird to me, but that's the significant ones they can try to work on. So evidently the clothing part of the business doesn't seem to be too bad. We just have other issues. Now, some issues may not be able to be, you know, rectified so easily, like parking. Depends on where you are. You might not be somewhere where unless you move the business, but you might be in a space where you just, you know, there's, you know, in a heavy urban area, you know, where you just don't have anywhere, like a really inner city where you can't just blow out a plot of land or something like that, you know, and just create a massive parking lot. You might not have the space to do it. Sales rep rude. I think you can take care of that pretty quickly if you're the manager, can't you? Poor lighting, a little traffic layout confusing. Those seem to be things you could probably, even though they're lower than the parking, you could probably make a more direct impact on Like I said, the parking might not be able to be dealt with, but okay. So that's okay. So these are used to look at areas of business concerned here. Let's scroll down here to categorical variables. Okay, this is another thing that I'm certainly not really worried about for testing purposes, but we'll see if it comes up in the homework. This donut chart for these is really confusing to me with two of them. One donut chart's okay, but so I copied this one out of the book. We'll just kind of take a casual look at this without worrying too much about it. I'm not too worried about it, but so we're looking at side-by-side growth risk level for the value and the growth, and high, average, low. That doesn't seem to be too bad right there. But this donut thing to me is, I don't know. It's a little confusing. Putting those two together like that, it's hard to, maybe it's not that confusing. I don't know. So there's more, although, yeah, it kind of is, because see, at least the blue starts and you can see which one's clearly longer in the blue, and the same thing with the gray, whatever color you want to call that. Same thing here. The problem is the orange doesn't really connect at the same spot on either one of them. So you're looking at it, you got one going like this, you got one going like this, but you look over here, you can easily see which one is the more percentage or frequency for the orange if you look at the bar graph. So that's just my opinion on this. You can have a different opinion. I'm not stating something that's factual here. So, I mean, I think to me that bar in this case is easier to read than that donut. But like I said, I'll tell you, that's just opinion. Anyway, so I'm not overly concerned about worrying too much about this, but just neat showing you different kinds of ways these graphs can be used. Oh, that was it then. So, okay. I guess before we jump to the next section, I guess we can go straight to the homework. Last time, I guess I waited till I was finished with both. Am I logged in here? Let's see. I don't think I am. Pearson, My Math Lab. Thought I signed into this earlier. Maybe, let's see. Oh yeah, I did sign in earlier. Thought I did. So 2.3. So kind of like I did last time, just, just going to look through here. There's only 4 of them. Yeah, here's one with a Pareto, and I'll just kind of look through here and see. Yeah, I'm not, for time purposes, I'm not going to do all 4. But maybe pick a couple of them. Oh, here's sort of a side-by-side bar. But like I said, you can do it for the homework. No, not going to put that on an exam. I want to look at the entire completed problem. Oh, that only has one answer. So that won't be much of a deal. Let me go back and look at something. So that's got a bar and a pi and a Pareto. Oh God, yeah. I think these questions I never put on a test. The one we talked about that a little bit last week, but a different context. What conclusions can you reach, and also this one, which method is you think is best. Sometimes it's obvious, but to me, sometimes it's not even that obvious. You can make a case for more than one, but so I don't like, that's a little too vague. But we'll get it right for the homework and then not worry about it. Worry about you being tested on that. Oh, horn went off. Halftime. Oh no, not yet. All right, so this one might be good. We can start with this one. I'll go backwards here, I guess. And a Pareto bar chart. Okay, let's see. Let's bring up the data. And there's telling you what it is. Open in Excel. And hopefully we can do this and just do it in the Excel. Enable editing. Keep the label. So yeah, I guess when you, some stuff we'll do later, you know, when you do that, you have to check a box that says labels are checked. I'm not sure on the graphing here. Let me see what's going to happen. Is it going to give me that option? I want a bar. I want a sideways bar. Okay, so I didn't have to really do anything. It did it automatically, but here's the problem. It's not the, this might be easier to do without Excel, actually, the way they've done it is, oh, I guess we got to sort these in. That's probably, yeah, let me go back to the homework. No, they're not sorted. Okay, no, they're by category. I wasn't sure how it's in order. But here it took them and did something to them. I don't want it to do whatever it did there. Let me try this again. If not, I'm going to come up with a different way to do this without actually looking at the graph. No, that didn't matter. Yeah, because it's just doing it as, I don't know if there's a way. Okay, if I try to figure out this, it'll take too long. So, oh, undo that. I'm trying to kill this, get it out of my way. So, oh, wait. Let me just shrink it. I can't get this thing to erase. Good grief. Go away, you stupid graph. Well, okay, I might not be able to get the technology to work right on this one. Maybe you can, but we can figure it out without it. Mainly just by the frequency values on the x-axis. So you know the A is super small at 3, so it'll be, sometimes all these kind of problems, these graphics, I go through a process of elimination. Wrong page. So right now that takes B out of the picture for sure, because A is a small frequency. It's either A, C, or D. So you can do it sort of by elimination. B was 15, I believe. Yeah, cooking was 15. Cooling was 15.
So it has the A and H, the smallest one, so it will be C?
We're getting probably, so that's, yeah, now we've eliminated, yeah, we just eliminated D. I think you're going to be right. D is gone because B is too small for D. Yeah, now we're down to A and C. And since C is identical to both of these, let's jump down and look at D. I'm sure you got it right. I just want to double check. I'm sure that's it. But so you see D is the difference in the charts there. So chart length. So what is D? D is 15. So yes, there you go. That's you were just ahead of me there, but you had it. Yeah, so see, D is the same length as B. So I don't know. There's probably a way to do that in Excel, but I couldn't waste any time when I knew I could get the answer this way. So I could not get it to list in the order. Okay. Now let's try to pi for that. Or like I said, we could probably do it without the technology again pretty easily. I'll just do it with. We sure are talking about a lot of desserts here today, aren't we? Pie, donut. If you'd have known, you had to. All right, somehow I eliminated it here. Good grief. Let me try it again. Try to minimize it and I always mess it up. Of course, then you got to figure out, I guess, according to. So once again, I don't know how helpful this is, but when I think you can kind of rationalize your way through it without doing that. So in other words, we know that A has got to be a skinny, thin one. So B is out. And then we know B has got to be a decent sized red chunk. All of B's look about the same. The red areas look the same. C is 10. So it's kind of between the two. So that's sort of the mindset I'm using here. Once again, you've probably already beaten me to the answer. C is sort of between the two, so it's not this green one, because that's the same as the red. That green's too small. It's closer to the blue. So now I think we're down to either C or D. That makes graph now. Yes, graph. So that green looks about right. And D, I believe, is the same as B at 15, right? Yeah. So I think they look the same there, don't they, in the answers? Yeah, the yellow is the same. I should get to the next one. It's not the same. E is purple. It's the same. Okay, let's get to this dark green one. F is going to be the way we can distinguish between the two, whichever one is the right one for F. Refrigeration is 11. So its wedge is going to be less than B, the cooling. So that's how we should be able to do it. And the cooling was red, if I recall. Yeah. So so that little F right there, that's bigger than the red. This green F right there is a little bit less than the red. I think it's got to be D. Ta-da!
Yeah, it's just if you look at your H is significantly smaller.
That's a good. See, look at that. That's very good. He looked at that, taking it from the other end, and So like I said, there's probably many ways to come to that. That would have been a lot quicker. You're right. He's right. So you look at the H, and then it kind of gives it away because look for the one where they're all different shapes. That's smart. Whatever the gray looks like the same for I also too. No, two of the I's are the same. Never mind. Well, actually, two of the H's are the same, but you could start at that bottom end and work that way too. Obviously, it doesn't have to start from the top. So two that looks like B and D have the same gray for I, and then B and C look close for the purple H. But yeah, that way you can eliminate two of them quickly. So yeah, you can approach this a million different ways. I just don't think that. I could be wrong, but I just didn't think that pie chart in Excel, unless it showed it, exactly the same point of view as we were looking at, probably isn't going to help much. I don't know. I could be wrong, but I think it's just kind of piecing it together by numbers here. So how about the Pareto? Okay, now before we start, one of these Paretos is automatically wrong, completely wrong. Can you see which one that is? It's because of the line. A. Yeah, the Pareto, the line graph part has to finish at 100%. So A is out the window. So now we've got to figure out which one's the right frequencies. But now you see but it's also its highest to lowest. Actually, this will be really easy. We don't have to even go to the numbers. So it's got to be highest to lowest. So that makes it either A or B, and we just eliminated A because of the line. Are you with me there? But then notice on the axis it's got the letters appropriate, I, B, D, E, whatever. Highest, so it's got to be that. So you just kind of piecemeal your way through that logically here. Let's see. Oh, good. This is I hate these questions. Which graphical method do you think is best? I don't know. Both a bar and a pie. I don't think the Pareto is that helpful here, but I don't see where bar beats pi, but I think that's the right answer. All right, well, you either take a picture of that or scroll through the recording later if we don't have any technical issues today, which I don't think we hope we won't. Always a good idea. You can photo the, all right. But I'm just telling you, that kind of nonsense will not be on the exam. Because I don't even necessarily agree with it. Pi's okay. What conclusions can you reach? Okay, this one we might be able to look through here. Let's look at let me bring up the data again. We got heating, look at the big one. Heating, cooling, and lighting, other, but I don't know what other is supposed to represent. Those are the big three, but there's 17% other. Heating, cooling, and water account for a large portion. Lighting, for that than any other appliance, is lighting. That's not correct. That one we could definitely eliminate. Lighting's not insufficient to reach a conclusion. I'm going to go with A and hope for the best here. You see how confident I sound here, right? It's a miracle. Okay. So there we go. Go pick those answers. They may change the numbers around and they obviously scramble stuff or whatever, but usually those kind of questions that have no numbers in there or all, whatever, will stay fixed. So wasn't that tremendous? Let me see what the other questions are. That might actually be enough for this section even. Might not need it because they're probably all about the same. Here's a Pareto, here's a pi. Then they're asking you Pareto or pi. Yeah, I think that's okay. I'll tell you what, I'll leave these checked answers here so you can see, you can take a picture of the word answers when I do that. Save yourself some grief there. Yeah, obviously don't assume that's going to be the right pi answer for necessarily letter C. Okay, the Pareto, they're saying is better than the pi for this one. Okay. But the Pareto is a little more unique than the pi, so I can see that. But it's the bar and the pi that bug me about necessarily which one's better. Yeah, so I think I can probably go and move on. Let's see. Because it looks like just kind of the same, C, sort of the same thing. A bar and a pi, a Pareto. What does it say? Both types are a good way to portray. Thank you. Hey, see? Here it says both types. But the other one picked one over the other. Good grief. And here, if you want to take a look at that answer for D, go right ahead. The vital view, blah, 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 blah. Yeah, okay, same kind of thing. Oh, we did that one. Okay. Let's see what number 4 is. So what do we say there? So there's the part B. So I'm sure you can get the part A easily enough by just bringing up the numbers and look at them. It'll probably be easy to figure out the first part of that. So once again, don't assume it's answer A. On yours, it's probably a different answer, but so evidently that one says the females are more likely to be overloaded with more information. Well, based on the answer for part A, which is letter choice A, then that's obviously correct because the red bar is longer than the blue bar. All right, that was pretty exciting. Onward and upward. Well, so let's go back to the 2.3 notes here. Or go to the 2 point. That's the end of 2.3. Now we'll go to 2.4. Visualizing numerical variables. Now this is kind of a weird type of plot graph. It's not bad, but it's kind of weird. It's one of these things that it looks weird at first. Then once you see how it works, it's not too bad. In other words, yeah, it looks a little strange. You know, it's not as kind of obvious, I think, to most people as like a bar or a pie. You know, it's one you probably haven't seen that much. It's probably not ever used that often, but it's kind of interesting to look at. It sort of works like a bar graph in a way. I'll show you whenever we look at one so you can see what I'm talking about. It's more related to a bar, or more specifically a histogram. Or actually a bar. I should change that. A bar graph. Yeah. All right. Now, we got this little block of data values right here. 10s, 20s, 30s, and 40s. And then we're breaking this down into 10s digits and 1s digits. I'll talk about in a minute what this key means. I'll wait till after we're finished. But let's forget the key right now and focus on this. So what you do is you put the stems in there in order. So 10s, 20s, 30s, 40s means 1, 2, 3, 4. And if you were missing one, which I'll show you in a minute, if you had, you know, if it went 10s through 50s and there were no 40s, you'd still put a 4 there. Now the leaf is the 1's digit that goes with the stem. So here's what happens with this. So the number 12, we put a 2 there for that leaf. The 2 pairs with the 1 to make 12. Then I come over 13. I put a 3 there for that leaf. The leaf pairs with that stem of 1 to make 13. So what's happening is these leaves don't interact with each other. Each leaf is independent, but they all belong to whatever stem they're with in that same row. So 1 with 2 makes 12. 1 with 3 makes 13. Come to the next one. 2 with 1 is 21. 2 with 7 is 27. 3 with 3 is 33. 3 with 4 is 34. 3 with 5 is 35. 3 with 7 is 37. 4 with 0 is 40. We got another 40. Sometimes people will ask me, you have to list it twice or whatever, and yes, you do, because it's just a repeated data value, so it needs to be in there. There are two 40s, so there need to be two zeros, and then 4 with 1 makes 41. So while it's kind of weird, it's not too bad once you get a kind of hang of it. But if you try to look at this without any kind of explanation or instruction, it would have been kind of hard to figure out really what it was trying to accomplish there. Now let me talk about what that key means right there. We actually didn't need that key right here, but I'll tell you if the key was when the key would be needed and helpful. Suppose that you were just given this stem and leaf plot and you didn't have the access to the original data. See, that this stem and leaf plot could have been done two ways. The way we did it, well, actually, because we had the data right here, we knew how we were supposed to do it. 1 with 2 makes 12. But you can actually do this for decimal values. For example, that data could have been 1.2, 1.3, 2.1, 2.7, so forth and so on. But if you did not see this original data and it was supposed to be decimals, that's where this key comes. So this key is just telling you for this chart, for just use an example, that it can be for any number there. It can even be for a number that's not there. It just says 1 with 2 means 12. If those were supposed to be decimal numbers, it would have 1 bar 2 equals 1.2. That's then telling you these are decimal representations, not whole number representations. So that's why so the key was not really needed here. It would only be needed if you had a stem and leaf that you did not know whether they were decimal data or whole number data. That's all I'm getting at there. So so here but we have all the numbers here, but I just put the key in there anyway. I just picked a random one, doesn't make any difference. It's just enough to tell you that that's not decimal. It's whole number again. All right, these are there's a lot of them. They're I know this would be a lot better if these were already in an Excel file and we could sort them. Be a lot easier, but the concept's not bad. Now, these numbers you just go through, peruse the list. They go anywhere from 20s to 80s. Now, I did this way. I did it on purpose, obviously. What I'm about to show you here is that means I got to put every stem possible, even if there's no leaves. 2, 3, 4, 5, 6, 7, 8. Now, there's nothing in the 50s in this data set, but that 5 has to be there. It has to be lowest to highest. Everyone is included, so even ones that are empty need to be included in this because it kind of affects the sort of the shape of it. And I'll talk about the bar graph shape of it here in a second. But let's look at this one. I may not do every number on here just to save time. But this one, and people ask, do you need to do these leaves in order? We'll just say yes. You'd get the same shape of the graph even if you didn't. But I suspect that anytime you look at these on an exam or in a homework, I think even in the homework, it asks you to do them in order. So we'll just say yes. We'll put the leaves in order. But like I said, this one's a little bit of a pain because you got to go through, let's say if they were already sorted, it'd be super quick and easy. But 21 is the smallest. So I have to put a 1 in there in my leaf. So because the 1 goes with the 2 to make that 21. And then here's 22. Put a 2 in there for that leaf. 2 with 2 makes 22. So we've covered the 20s. Now we have the 30s. 0 for 30. With 3, stem makes 30. 2 of a leaf with 3 makes 32. And I'll just look at the 40s real quick, and I'll stop after that. We have 40s? I've got a 43, a 44, and a 45. So I would have leaves of 3, 4, 5, each one of them going with the stem of 4 to make 43, 44, 45. There's nothing in the 50s. Wonder if I should put a 0 there if there's nothing in the 50s. No, I should not, because putting a 0 there would indicate the number 50, right? Now you just literally leave it blank, just like that. Now, okay, so I'm not going to go through all the rest of these. You could ask me about it anytime you want to sometime, but so you list them all. But what this does is it kind of gives you a visual projection of the data. You know, if you're looking for trends, looking for, you know, whatever, if you weren't looking at the original numbers, you're looking, oh, we can see it's higher, you know, out toward the higher numbers. So it gives you a pattern. So when I was talking about looking like a bar graph, you just sort of imagine you could make it look like, you don't need to do this. I'm just saying, oh, why am I using my mouse when I got a stylus right here? I keep forgetting. Hang on, let me draw it by hand. So I'll erase this first. You know, you could have it sort of, and it gives you a projection of the bars like that. So you sort of see it's like it's like a sideways bar graph in a way. But a bar graph would give you the same visual length like that. You know, how far it sticks out. So that's what I mean by it. Visually, it can relate to be the same as a bar graph. But stem and leaves, like I said, probably won't, when we're going to use them in this class, and I'm sure you'll probably have some, you will have something with this on the test. But you may not encounter stem and leaves too much when you're out studying other kind of other data and things like that. But just in case you do, you'd know what it was. But it's not commonly used by any means. Now, here's another good question. Like I said, I can, have related to a question on a test or something like that. In other words, we talked about earlier when I did that pie chart problem, how many total people, you multiply it by the percentage. Here, it's good to be able to not only construct the graph like we just did, but to interpret one that's already done. Now, here's one where we needed the key, because with just from this information alone, you wouldn't know if that's 10. Again, I should have mentioned this. It's okay for this to be a 2-digit decimal stem also too. That's okay. You don't know whether that's 102 or 10.2 without the key. So the key tells us that's 102. So that means all you need is one number to show that they're all whole numbers. Yeah, just any one of them could have been the key. But now we know they're whole numbers. So could you look at this and find the minimum and maximum values of that data without having to rewrite the data back out? Absolutely. The smallest number in this data set is going to be the 10 with the 2 to make 102. And the largest is going to be 13 with the 6 to make 136. Now, is it possible, what can I, what if a quick way I could figure out how many total numbers I have here without having to rebuild the entire list? Like, do I have to write out, good grief, 10 and 2 is 102, 10 and 3 is 103, and write all those out and count them? Is there a better way to come up with the total number of values there than doing that? Absolutely. All you have to do to figure out how many values you have in a stem and leaf plot is just count the number of leaves, because each leaf pairs up with a stem. You don't have to count the stems, just count the leaves. So we have 5 right here, right? 5 leaves there and 2, so that makes 7. And there's 8 here, 15, and 3 more make 18. So that's certainly a lot better than listing all the numbers back out, isn't it? So that's how I got the 18 here. Now, what proportion of the values are less than 120? So we know there's 18 total, and less than 120 pretty much represents everything in the first 2 rows, doesn't it? How many? There's 5 in the first row with the 10s. There's 2 in the second row. I think that makes 7 out of 18. Now, once again, if this was on a test or in the homework, it could be fraction, it could be decimal, it could even be percentage. But once you have the fraction, you could then convert it however you needed to convert it. As long as you got the 7 over 18, you can get the decimal, you can get the percentage from there, whatever the case may be. So all I wrote was the fraction. Next question's easy. what's the min and maximum if these would have been decimal values. So instead of 102 and 136, it's just 10.2 and then 13.6. All right. A dot plot. Now these you might have actually seen before. And this could come up, if not in the homework, certainly on a test. Because once again, I like asking questions about more so than just constructing the dot plot. I like answering, having you ask questions like we did just here with that stem and leaf, finding information like that. Dot plot's super, super simple. All you do, and it sort of has a bar graph effect too. The stem and leaf has the numbers sticking out. This one measures by the heights of the dots. So all you do, it won't take too long to explain this one, is you need a number line, put them on a number line. There's no y-axis value. So the first number is 2, you put a dot where the 2 is. Next one's a 4, you put a dot where the 4 is. Third one's a 3, you put a dot. Next one's a 2, so once numbers start repeating, you stack the dots. So you just put a dot right above that dot. So each time a number repeats, you just put a new dot. Because we're interested in seeing the pattern of, how many we have of the same one. Now this is not actually scaled properly because 30 would be a lot, the way I scale these, 30 would actually be a lot farther out. But I wanted to keep it, on the same page. So now we go with all these, so you plot all those dots, super easy, and then you have this 30. Now here's a term that we're going to have other ways to identify it or define it later, but this is just the first basic idea of this concept of what's called an outlier. We'll see that come up again. Outlier just basically means a number that's far removed from the other data values. Now keep in mind, it could be, depending on the data, it could be far removed on the low side. It's not implied that it's the high side of the data values. Like, so suppose that, for example, that, what's a good example? I say exam scores. And let's say we have a class, we have some sort of exam, and let's say everybody makes at least an 80% or higher. Somebody makes a 10%. Well, then that would technically be an outlier, but it's on the low end of the data, not the high end of the data. So it's just, so it's anything far removed. I don't want you to be confused and think it just means automatically greater than. No, it could be way less than your numbers also too. All right, proportion. Now this one we already have the numbers here, but suppose that we didn't. Just pretend, because I wanted to have numbers here to show you how it's constructed. But let's pretend like the numbers aren't there. Could I figure out then, the way we did it the way for the stem and leaves, how many numerical values I have there without listing them out? Sure, you just count up all the dots. But don't forget the little outlier dot there. Don't forget the one that's way out there, that counts too. So if you count the dots, there would be 16 dots there. So you could do that without even seeing the original data set. Then, what proportion of the values are less than 4? Now this one I went ahead and added a percentage in there just because I could. Less than 4. How about 1, 2s, and 3s? There's a couple of 1s, 4 2s, 1 3. There's 7 values that are less than 4. Now how about more than 4? So that's where we're going to start paying attention, like the difference between these next two questions. That'll be coming up and other stuff in this class. So we got to make sure we know the difference between more than and at least, and then less than and less than or equal to. More than 4. 1, 2, 3, 4, 5, 6. Yeah, that'll fool people sometimes when I do this in class face to face. Though I'll ask people, sometimes if I remember in advance, I'll erase this, but I usually forget. All right, how many are there? And they'll count these 5, but forget that little outlier out there. So it's 6 out of 16 that are more than 4. Now, at least 4. So at least 4 means I include the 4s. It's 4 or anything larger than that. So we know we have 6. So let's add the 4s together. There's 3 4s. So 6 plus 3 would be 9. Ta-da! Isn't that exciting? Percentage polygon. Okay. This is a line graph where it shows the percentages by corresponding. So here's the, which I think the bar graph's a little bit better myself. Okay, that's a lot of data there. You know, we're not going to go through all that. But it's a bar graph version of this, essentially this. It's essentially going, instead of the, like the Pareto goes to the right corner of the bar. This one kind of, well, actually, I guess it goes kind of the, well, I guess going to the center of the bar or the right corner doesn't matter because it's the same height. I'm not sure how much this polygon really helps, but so here they are. Okay, I went ahead and did a sort of a grouping thing down here to show you this because it's not very clear the way that this graph printed out is not labeled very well. Did I draw a graph on this? I did not, but I can fix that one. So I went through all this mess and counted all these up. I'm not going to do all that, but just so you can see it, if you want to go back and practice it to see if you can come up with the same thing. Now, you see that one thing that makes this nice when they put this in here is the bottom part. That's what we want to work with. It's sorted. Now, they don't make it clear. Now, this, I'm using this not the way we did it, where I took highest minus lowest, you know, and then divided by the class width. I'm going by what I see right here on this axis. You see with 25 in the middle, that means I know I'm looking at a 20 to 30 range right there, which that's confusing. I'm never going to make you look at a graph like that and try to, that's okay if they were individual values, but they're not individual values. It's the midpoint of the interval. It's not, you know, we did one of those kind of graphs last time where it was how many courses a student is taking or whatever, and the center number meant like 1. It was that number, then the height meant, yeah, that doesn't mean, for example, that there's 4, so this has a height, that doesn't mean that there's 4 25s in here. It just means there's 4 numbers between 20 and 30. So that's a little confusing, but once we have this out, I want to just kind of, so what I did is the frequencies for each one of those just by counting it already sorted. In other words, I'm not expecting you to be able to figure out those intervals from this particular graph. But anyway, I just wanted to show you how that polygon line works. So here's what gives you the bar graph. So each of the values for the center versus the metro. So these are the frequencies for each of these two graphs. That's not too bad once we realize it's 20 to 30, 30 to 40. I put the percentages in there because we go to this graph. Was it? Yeah, because you see it's percentages here. That's why I converted them to percentages. And once again, they're using the midpoint, because I guess that's what you're supposed to do on this type of graph, is use the midpoint of the interval. But that means it was the 20 to 30 group. So it's really sort of like this. Yeah, let me. Put a 30, 20. Yeah, like that bar graph below. So it's just, so it starts at, this is, which one is this? The orange one is I gotta check the legend over here. Orange is metro, blue is center. So the metro should be, it's between 5 and 10%. Let's see what it is down here. 8%. Yeah. In fact, why is, okay, yeah, you see, Both graphs, that's what makes this a little confusing. Hopefully this will help. Both graphs are actually starting at the same point. They're both 8% for this first interval, but then one goes that way and one goes, the center goes this way. So yeah, they're at the same, I don't think that's not a rule, but this one, they have to be, they happen to be the same starting point. So we come down here, but you see they go quickly, they go different directions. Center is 6%, metro is 28%. So center goes down from 8% to 6%, but then you see metro right here goes from 8% up to 28%, like that. All right. A little bit, yeah, a little bit odd, but we're about time for a break here in a second. Is this the last graph? Because I can come back and do the homework after. Yeah, okay, let's see. Oh, that's why I did the cumulative in that same graph. Okay, ogive. I don't know how to pronounce that. Ogive, I never have known. Doesn't matter. It's cumulative percentages. So that's why I had the cumulative. So it connects those lines by a cumulative. You see, that's not too bad. Once if you can just try to go back and look at this later if you like, and follow my cumulative numbers here or whatever. And so this one, they're absolutely both going to finish in the same spot because they're both 100%. And see, they both start out the same spot. They're cumulative, then they start changing here. But so this keeps the running total. That's why they keep rising. Kind of like the Pareto. So the Pareto, though, those were categorical data, but here you're just, now I don't know why I've got all these, okay, this is, I don't like about the way the technology, there's too many dots. Are they really breaking this down by units of 5? Maybe they are, but okay, once again, not something I'm going to make you do on a test or anything, but I would have just I'd have kept a running total of 1 dot per interval. Like my graph would have gone, if I was constructing this, I just would have gone, the center I'd have gone from, make it here to here, and then it's there to there, and then skipping every 2, I'd have gone like this, like that, and then here, there, okay. But anyway, it looks like they might be going by units of 5. So, I don't know. We'll look and whatever we'll see from the homework. Now here's one where I've got assorted data. I found this problem somewhere. I'm sure I used Excel. No, actually I might have just copied this. No, I didn't use Excel. I copied this answer from that problem so we could see it. Yeah, so this is by groups of 5. But that's why I did this, because this is the way I think it should look versus that other one. This to me is much better. 0 to 5, less than 5. 0 to less than 5, 5 to less than 10. Here's the heights. And then and like I said, here's the dot. To me, this one's better. So it starts at 0 and it goes 0. So it goes to each 0 to 5, 5 to 10. So from 0 to 5, we have 4 values, but this is a percentage. So what are the, how many values are here? Let's see. There's 25. Okay, I'll count. There's 25 of them. So you can do a real quick calculation. 4 out of 25 is 16%. So you see that first dot? That's right at about 16%. And then 4 plus 6 is 10. 10 divided by 25 is 40%. So there's the dot. That's a cumulative. So there's the dot right there. And you see you slide over. That dot is 40%. I'll just get rid of that other, in the future, other example from my notes and just work with this one only. I don't like that other one. And then so forth, so on. You just keep having a running total like that, and then it ends up at 100% at the end of the 30 right there. So, all right, I think we need a break here. And then what we'll do is when I come back from break, I'll start at the 2.4 homework. And, we'll look at a problem or two, and then we'll move on to the next section. So, I don't know how long of a break here. I figure. Okay, I guess we can let the show continue. We're going to take a look at homework from that section. Mr. Swain, I'm going to update this little chart for you here. How about that? Islanders 0 fans.
So would that be the outlier then?
Yeah, that's probably good. That's probably a good way to look at it, right? All right. I think, you know, this defies the laws of mathematics, but I'll go ahead and just do that anyway. I thought so. At least I could do to you for, you know, disgracingly putting the Rangers last. So I got to at least put somebody else last. All right. Yeah, good example. See, right an outlier. Although 0, close, because 0 is not that far away from 10, but it's certainly, yeah, we'll talk more about outliers later or whatever, you know, so it kind of needs to be a significant, you know, now if I did this, that's a good question though, that's beneficial for everybody. Let me change that back to 0, or just make it, I will make it 1. There's probably one drunk Islander fan up there. Let's change this to 20. And then that gets a little more outlier kind of right there. So you separate the distance a little bit more. 10 to 0 wasn't much of a gap, but this is a lot more of a gap. But that's a good observation. All righty, are we ready for some homework? Let's see. 9 problems here. I'm just going to kind of just see what looks the most intriguing. Oh, I probably won't do that one. That was pretty simple. Just filling out the stem and leaf, or, you know. Oh, good grief. Let me just see what looks, a lot of numbers there, isn't it? But it looks like you can download the data and sort it, so it should go pretty fast, right? As long as you can sort it, it'll go quick. I don't mind going back and looking at one of those. Histogram and these polygons, maybe that could be good. Yeah, I don't know. Like I say, time-wise, I don't want to do too many of these, but it could be several good choices here. Of course, after you've had a chance to look through them, you know, you could always ask me, certainly at the end of class next week or something. Percentage histogram. This might be more worth taking a look at maybe than the, go back to the, that could be good. But I don't know if it's worth doing the, like I said, doesn't mean you can't ask me about them later, but these first couple of stem and leaves don't seem to be too bad. So first one's really easy. So that's okay with you. I'll skip out and try something else here. Histogram and percentage polygon. The cumulative percentage polygon, which is the ogive. Oh, this one might be fun. So like I said, like we did earlier, that you know, you could piece this together however you think's a quick way to come up with the answer. That's all that really matters. It's not you know, because like I said earlier, sometimes the Excel will help, sometimes it won't, but, and you see we've done before, some of the stuff you can kind of use a process of elimination approach to narrow down answers. Well, I hadn't even read the question yet, but all I do know is I'm going to be sorting that data. All right. Now let's go back and see what it wants here. Histogram, percentage polygon. Let me zoom in on one of these so I can see the scale there. It's got 75. Ew, okay. Looks like a 75 to 85, 85 to 95, 95 to 105, 105 to 115. Let's see if that's right. So, okay, so let's see if I'm going to count how many are between 75 but less than 85. Well, that's no good. I get 0 of those. So what am I missing here? Maybe it's not. Oh, it might be 80. Oh, those are the, yeah. I misread it. My fault. Okay, we're all learning together here, aren't we? God, I can't see that. That's so small, but those numbers are actually, I think, in the middle of the interval, not like I showed you on that one problem. Okay, so I think it's going 80 to 90. Yeah, okay. Sorry about that. But we're learning here. 80 to 90 without including 90, there's no 90 there. 85 to 89 is 2. So I think we're looking at a small, obviously a very small one for, well, I think we can actually answer the problem now. Well, I mean, maybe I should go a little further just so you can see. Maybe I'll go a little further, but be careful with those scales. You see that B and D both have low, high. Actually, it's because one of them 0 to 10. Well, maybe we don't know. I take that back. We don't have the answer yet. We just narrowed it down to 2. God, these things, even with I need to zoom in on these. I can't see them. Well, let me show you. God, it doesn't even zoom in that much, does it? But 2, look at that scale, 0 to 3. 2 would be correct for that first interval. And I think 2 might be correct on this one from 0 to 10. And it's hard to tell, but you can't say that it's necessarily wrong, can you? That little tiny wedge right there. So it looks like the difference is going to be whether there's any difference at all in the next interval. That'll separate it. So 90 to less than 100, there's 2 values there, 2. So that will give it away. It's got to be C. Because you see on the B graph, it's raised a little bit higher from first to second. Now D, they're equal heights, but they're equal heights at 1, not 2. 2. I'll go one more just to show you. I feel like we're just kind of short chain. Between 100 and 110, less than 110, only one number there, 107. So 2, 2, 1, definitely C. Yay! Percentage. It's not cumulative percentage. So that means those dots are going to represent the heights of the correct answer. Yeah, it's not cumulative. The O guy, we got to think a little bit better. Well, I think it's going to be, let me double check. It's either C or D. Let me look at the scaling, because remember, these are percentages. So that's going to be the key, I think. I may have to go to a different percentage. So how many, does it tell us how many? Oh, 50, tells you 50, but we could have counted 50 cells there. So 2 out of 50, I'm not saying you should do this in your head, but 2 out of 50 will be 4%. 2 divided by 50 times 100. And what is this showing here? See, it's starting at 0, then sliding over. That's not high enough to be 4%. God, these are terrible to read, aren't they? But it's got to be D. Can you see that dot there raised up to 4? And we know the next one's the same, 4%, and then the next one will be 2% because 1 out of 50 is 2%. So hopefully that logic I'm trying to apply to get through this is okay, but these things are just visually terrible. But we're at least applying some sort of brain power to this, obviously. So, all right, now cumulative. Okay, so any of them not finish at 100%? C and D. So we're C and D is out. So it's either A and B. And once again, it's terrible to read. Let me look at this one just for a second. I'm not picking that answer for sure, even though I dotted it. I'm just looking. Now they've got 80, and then I guess each one's 90, 100, 110, 90 would be the first one. 90, 80 to 90 cumulative, that's 4%. And then the next one is going to go up another 4%, which is 8%. What's a good mark to where the two graphs are different? That's what I'm kind of looking at. Is where
Professor, I think you can keep zooming in. I think you can keep zooming in there if you keep hitting the zoom button or the zoom icon.
Oh, that's tremendous. Thank you very much.
And I think that bottom icon is a total expansion.
Pop out. Ha! Look at that. Beautiful. Well done. Give that person a round of applause there. Well, you don't really have to, whatever. I will.
Or 100 right there.
So I'm making this way harder than it needs to be, aren't I? By not knowing how this software operates. Good Lord. Okay. Oh, that just opened up a whole new world for me there. I know you probably got tired of watching me flounder there. I guess I was afraid I just clicked once and thought that was it. I didn't think about multiple clicks. I should have tried that arrow button. Well, let's see. We know it's 4%, and then it's another 4%, so it's going to be 8%. So we know it's going to go, let me just get a good look. 4, that looks good at 8. So I think the first one was 8. Let me double check for the second one. Let's see if there's a difference I'll pick 120. Let's just see what it looks like at 120. It's at 10%. You see these would be 5 here because 0 to 25, 5, 10%. And at 120, it's up to like 18% here. So that's how we're going to be able to make our difference is at 120. So what once again, I'm sure you've probably already thought of a better way. I am not saying this is the only way to deduce this. It's just what hit me. So under 120 will be right there. And that is what, 9 values? And once again, you don't have to do this in your head, but 9 out of 50 is 18%. So it's got to be the one that was 18%, which I believe was B. And yeah, just under the 20%. So we can assume that's 18%. So it's B. Fantastic. Well, now I just opened up a whole new world there with that Zoom, didn't I? All righty, so the majority of the charges are clustered between, oh, good grief. I guess we can go back and look and just see what it looks like. From just the data itself, even without the, well, actually, let me go back up here. The histogram would help, like right here. That would get you use the one that's the right answer, of course. That's definitely in the 140 to 150, 150 to 160, and 160 to 170 there would be the highest 3 bars. Yeah, that's easier than the line graph. So I'm going to say that's the highest 3. So is there an answer that says 140 to 170? No. So what's another way to kind of conclude this? Maybe they just include more. But that seems to be the one that makes the most sense, unless it goes down a little lower. I guess they're just expanding it. Let's go down to 130, 120. Let me see what that range goes to. All right, 110 to 180 might look good. You see why these questions are so vague? That's why I would not put these on a test. 110 starts right here. And 180, 60, 70. Okay, so you see where I'm kind of moving the cursor? That block is what they're saying. I was looking at more the 3 highest, but they're expanding it out to include that block. Well, let's see if I get the green check mark. But if I'm right, it's because it's that block right there. Ta-da! Okay, I don't want to spend too much time on this. Let's see what, tell you what, let me scroll ahead and let's see. So we did OJ. Let's see if there's anything kind of different we need to do here or whatever. But I'll tell you what, I'll show the completed problems here. So in case, obviously you'll have different numbers, but the ones that has those conceptual questions, if you want to see the answers. Well, that has numbers, so that might not be, that might change. There you go. So you can use that. You can use that information. 20 to 60, which they're telling us that D is the right. Yeah. 60, the last bar is a little low, but it's still higher than the other 3. So they're grouping all that together. First 2 graphs look like they're giving me the finger. I won't take it personally. Some of you might be giving me the finger, so I don't know. Anyway, John probably already has a couple times. Let's see. Okay, so I don't know. Let's see if we need to tack another one of these or not. I'll go ahead and just move on. Let's see. It's kind of the same. Probably should have eliminated a couple of these problems just because there's too many. So we did the cumulative. We did the percentage. I'm trying to say there's something unique I need to focus on here. That's no. It's like too many of the same thing. All this is just comparing 2 of them. So I'm not sure how exciting that is. Cumulative on the same, it's just 2 of them on the same graph. I guess I skipped the stem and leaf. I don't know if it's any to do any more of these or not. They look about kind of all the same. Wait a minute. I guess oh, this is one of those ones like I told you about, or we did last week, but because the video crashed, it did not end up in the video presentation. But I explained how to do that problem with the weird numbers. This one has weird numbers also, so I guess you could sort of do the same idea to this if you multiplied it by 10,000. But you'd have to pay attention that you know that your scale is multiplied by 10,000. I'll bring this one up real quick and then we'll move on. Yeah, let's take a look at this. Yeah, if I'd have been looking more carefully, I probably would have deleted this one from the homework earlier. But Problem is I can't delete it if anyone's actually started this homework. Or I could just remove them. I might be able to remove it anyway. That way, if you already did it, it won't hurt you. I'm not really interested in torturing you with these kind of numbers here. Wait, what the heck? Oh, are they by different groups? Is that what this is? Why are they listed that way and not in one? Well, I guess you can cut and no, they're not different groups. So this one's kind of annoying, but you can take care of that by cutting and pasting, or just copying, either way. Yeah, I'm already getting annoyed with this problem. I might end up removing it anyway if I can, from the homework. Yeah, why didn't I just dump it down in one column? And then now we can grab it and sort it. Well, I can multiply by 10,000 first or sort it. So actually, this is the multiplying by 10,000 part. I explained it in the announcement, but now you'll see me do it. So maybe it'll help. So I'm going to go equal cell A1 times 10,000. And then copy that all the way down there. Look at that. Nice, beautiful whole numbers. Wait a minute, they're not. I thought I sorted. I wonder if that cutting and pasting. All right, something's wrong with this. It might have been because of that. If I cut and moved it, it's not doing it right. When I multiply by 10, no, that's not it. I thought I had something, but I thought I was on to something. No, that's not it. I mean, negative 44 should be the first number here. All right, I'm going to go through, and so I think there's a way I can go through and remove this problem, meaning that if you did it or did something, it won't hurt anything if you've already attempted it or done it. But that's already irritating me. Why that's not? What am I missing? Why that's not sorting properly? I mean, negative 44 is the smallest number. I'm not crazy, I don't think. Well, I might be crazy, but I'm not wrong. That is bizarre. Why is that not sorting that properly? Just for grins, let me just try it. It won't make a difference, but sort column B, largest to smallest. All right, give up. I surrender. That's it. That problem's got to go. Anyway. Okay, let's go ahead and move on then. Like I said, you can always come back later and ask me, even after class today, or if you tried any of this, but just know now that problem's going to be, I think I can remove it. I forgot what it looks like from your point of view when I remove it. I think it just might show because I've done it before, and I think students told me it just shows like a line through it or something like that. Deleting it would be like I've done with those problems you won't ever see because I deleted them already. But I think if somebody started the homework, I can't delete it, but I can remove problems. So that's gone. Now this is 2.4. Now we are going to be looking at one called 2.5, but I'll show you. That's not really, it's better. It's a short, not too much to it. It's better to do that one where's my Blackboard content? Just when I thought had it. It's better to wait and do that one before we do some other stuff here. Here we go. I was looking at this at break. So you see there's a 2.5 way down. I'm not sure if there's even a homework thing on 2.5 or not, but it might not be. But anyway, so we're going to go from 2.4 to 3.1. And I'll do it in that same order that's listed in the notes. Okay, this won't be too bad. I think there's a good chance we can do this section and do some homework on this section and call it a day. It won't take too long to do this, but I definitely want to do some homework. Measures of central tendency: mean, median, and mode. Ooh. Mean is average of a data set. Now we're going to start getting into some symbols they use in statistics. They like to use a lot of Greek letters. You don't have to know the Greek letter. We just need to know how it functions. Now this one, okay, so now we're talking whether the data is, first of all, whether it's comes from a sample or comes from a population. It's not going to make any difference for this, but something we do later on called variance and standard deviation, that will actually make a legitimate numerical difference between how it's calculated. It won't here, though. The notation will be different. So if your data set is from a sample, the symbol that's used for sample mean is this X with a line above it, also known as X bar. And this you probably recognize from Excel. It's a Greek letters, capital sigma. You don't have that part you don't have to know. But when you see this in math, it means add stuff up. So this means and n is your sample size. So this is just a fancy way of saying add up all your numbers and divide it by how many you have. Add them up, divide by how many of them there are. Now, there's other means. I don't remember if we're going to cover that in this class or not. That might have been eliminated, but I might talk about it anyway, called weighted mean, which sort of applies the like how you would calculate your grade in this class. You know, if each value has different percentages associated with it, that's different than this. That's what's called a weighted mean, because each value has a weight. What we're talking about right here is strictly, you know, all values are considered equal here. In other words, they're not, one of them's not a higher percentage than the other. So you just add them up and divide by how many you have. And this can be done, we know, in Excel, obviously, or whatever you want to do. But so find the sample mean for this particular set of data: 3, 11, 4, 9, 16. Just add them up, divide by 5. Now, one way you can do it is add numbers, hit enter, then divide by 5. But it's very important that if you do it the way I wrote it right there, that you better use parentheses. Because I've had people do this. What are those numbers? 3, 11, 4, 9, and 16. 11 plus 4 plus 9 plus 16. And then they do this. No good. You either have to use parentheses if you're doing it like this. Oh, well, crud, I wanted to get those numbers back. Let me do it again. Oh, now it's going back too far. Just, you can either put parentheses or do it this way. I wonder if there's a forward command. Second enter goes backwards on your commands. I wonder if there's a forward. You can do that, and then you can do divide by 5, and and then this would be okay. But if you want to do it in one step, you got to have parentheses wrapped around there. So I had people going, why am I not getting these means right? What am I doing wrong? Super easy fix. And we'll do, we'll do some examples of this when we actually get into the homework here in a little bit. So this book breaks up the sample and the population, so I'm still trying to get used to that, even the second semester. The other books we use would have started doing the population here, but let me double check. I don't think it is. Let me look ahead. Yeah, because I think that comes up, population mean will come up a little bit later. Yeah, but it's the same thing. Median. It's the middle value of a data set sorted in ascending order. So to calculate the mean, the order of the values never matters. You just add them up and divide. But for the median, they are sorted. Of course, if you're going to use technology, which I recommend, is you don't have to sort them. But the concept is the command will sort them. But this, I'm going to show it to you, how to do it without technology, just so you can kind of get a feel for what's going on. 50% of your values in are less than that median, and then 50% of the values are greater than that median. Now you look at this data set of these 9 numbers right here. If you look at this and you don't think carefully and just go, hey, I'm gonna pick the one in the middle, right there. And then I'm going to go, my median is 1. Well, you could get lucky, and that actually was the right answer, because it certainly could end up that way, but that's not the right approach. Well, first of all, you look at it and go, well, that means half of the remaining numbers are greater than 1, and half of them are less than 1. That is certainly not correct, is it? Half of the values are, all of the values are greater than 1, and none of them are less than 1. So that's clearly wrong. But like I said, it could work out to where, the right number would have been in the middle, but obviously you don't want to think of it that way. So you sort them out. 1, 2, 3, 4, 5, 6, 9, 11, 11, 15, and 17. And 9 is right in the middle. So out of the remaining values, half of them are above 9, half are below 9, numerically, not visually, numerically. Well, both numerically and visually. So the median of that data set would be 9. Now, notice this has 9 values, has an odd number of values. So when you have an odd number of values, you will always have a unique value in there that represents your median. Now, the issue is when you have an even number of values, you will not have one value that represents that median. Now, what I did right here is I took that same data set and added 18 to it, and then sorted the values. But if you look, there's not one single number that's perfectly in the middle like it was for this one where we had an odd number, 9 values. There's not one number in the middle, 2 numbers. So what you do, you take the middle 2 numbers and you average the middle 2 numbers. So it's, very not uncommon, for an even number of data values that the median might be a number that's not in your list. If there's an odd number of values, the median will be in your list. And then it can also be something 0.5, because if you add your 2 numbers together and they are odd and you divide by 2, you'll get something 0.5. But here you take the 9 plus the 11 divided by 2 and you get 10. Now I've got this in the calculator. You can do it you can do these in the calculator. I may wait and just do a new problem for you instead of the same problem. Do it, and I can show you the Excel command to do it too. But we'll take a look at the calculator way here with another example. Now the median is often used in statistics. It's not something rare. You'll see data sets, they'll want to give the median. I've seen median and lots of things. They'll talk about salaries at companies and the median salary at this company, blah blah blah. For a certain type of, it needs to be for a certain position, I guess. more likely. Median home prices in areas are often referred to as the median. And here's why sometimes people like to use the median. We're going to bring back that word outlier again. Now here's one we had an exam. If the mean was 78, but the median was a little bit higher, what does that tell us? That tells us there were some low scores in there that would have affected the mean, which is the average, but it would not have affected the median, because the median is just the middle number of the sorted data set. And here I didn't have this earlier, I don't think, but here's an actual, I just said what outlier was, but here's just a written thing of it. Value that's far removed from the other values of a data set. Now, larger data sets, you're not going to have too much of an extreme difference between the mean and the median, but this one I did a smaller data set to show you that how it can be kind of an extreme difference there. You know, suppose this was a small class of 10 students and you had this list of scores right here. If you average those up and you get 74, but if you find the median, you take the middle two here, which is 85 and 90, and average them, you get 87.5. So if the instructor's kind of looking at this test, if they see the average was 74, do they feel like the test was really all that difficult? But then if you look at the median telling you that half the people made 87.5 or higher, that probably tells you, and also probably just tells you in general, if you look at the 80 and up, you know, that you just had a couple of outliers. That doesn't necessarily mean that the exam was hard. You just had a couple of students that just probably weren't prepared for the exam, in other words. So not being prepared doesn't mean that shouldn't be factored into whether the exam was difficult or not. Sometimes somebody might say, oh, that exam was hard. Did you study for it? No? Well, that could be part of it. But obviously you kind of need a more block of consistently lower scores to really make a determination like, you know, the test was hard. You can't do it by one or two outliers like that. So anyway, because you see there's a good amount of low scores. Now we're going to talk a little more way, you know, sort of, instead of looking at outliers visually, there's ways you can sort of determine them numerically instead of just kind of estimating, because it's kind of hard. We'll look at some ways later, but I'm making sure I'm keeping them pretty far removed, you know, to make sure. That's why that hockey example, and John asked me about if that one was an outlier. That's why I separated the numbers a little bit just to kind of give more space and more credence to it being an outlier. But this one, like here's one, whatever these numbers, I don't have a story behind these numbers, but you can see that 55 is way away. Considering how low the other numbers are, it's way far away from that 10. And you can have actually more than one outlier. Now I'm not going to rewrite or resort these numbers, it'll be too much trouble, but if I suppose that these numbers suppose I had 10 and 55 were just exactly like they were. But I took these first 6 numbers and made them like 2,000, 4,000, 5,000, 7,000, 8,000, and 9,000. That would actually make the 10 and the 55 far removed from, they would be the 2 outliers. So let me make it clear, the outlier, you know, like I said, we have 2 outliers right here. So I guess we already have seen multiple outliers, but so there certainly can be more than one. Out of these, okay, here, well, like a second, here, the third measure of central tendency, the mode. The mode is the entry value that occurs. I'll say value, entry value, or item. I'll talk about that here in a second, but it's the greatest frequency, but provided it occurs twice. Mode is the only one of the 3 measures, median, mean, and mode, that can apply to both quantitative and qualitative data. It's the only one that works for both. For example, let's see, do I still have that section? Yeah, I still got this one up here, right? Let's see. Yeah, I just want to bring that up for a second. Yeah, Well, suppose you take those, you can't exactly take those values, Mercedes, Toyota, BMW, and you can't exactly average those categories. You can't take letters and average them. That really wouldn't make much sense. And you also can't take them and find a median. Oh, the median is going to be Toyota. Well, what? What does that even mean? However, you can apply mode, because mode would be the answer, the one that has the greatest frequency associated with it, not the label itself. So out of these 5 values, Honda has the largest frequency, doesn't it, at 58. So you can say that Honda is the mode of that data set. Yeah, there's no mean or median involving qualitative data, but there can absolutely be a mode to that data. And like I said, it would be Honda. That's why I want to go back so you can see, that's why I scroll back, because Honda, that's why I just explained it. So Honda's the mode. Now here's some that these are numbered out. So they can be numerical, they can be or they can be quantitative or qualitative. Let's look at these data sets. And look at this first one. There's you have to occur at least twice, but occurring, sometimes people overanalyze that. They say, oh, if a number occurs twice or more, they'll include everything, but that's not true either, and I'll show you. But this one, 6 unique values, no mode. I'm sorry, 6 numbers that all occur once. They don't repeat. Yeah, there's 6 numbers. That's why they're unique values, because they don't repeat. So 6 different numbers, no repeats, no mode. You can't have ties unless they occur more than once. Now the next one. Now let me be careful with this one. Now this one, you see there's 2 1s and there's 2 6s. What that means is 1 and 6 then have a chance to be the mode. A chance. That doesn't make them the mode. They're eligible. However, look at the 7s. 1, 2, 3, 4. It's the winner. It's the most frequent. So the mode is 7s. 7. But they say, 1 and 6 had a chance, but now the next data set, same kind of idea. You got a couple of 6s there. They could be eligible. But let's look at, there's the 4s. There's 1, 2, 3 4s. 1, 2, 3 5s. Here you have a legitimate tie for the mode. That's also called bimodal. Bi be 2. So 4 and 5 are the modes, both the modes. Okay. I think that might come up I think I've seen it, maybe it was in the past. I'm not sure if it's in the homework, but I've seen a mode come up in one of these homework problems where it was more than one. I think they tell you to separate it by commas if it's more than one or something. So you kind of do like I have here, put 4, 5. All right, this is not something you have to know by definition, but it just sort of shows mean, easy to calculate, easy to understand, but may be affected by outliers, extreme values. Well, yeah, this is heavily affected. It'll be somewhat affected, but whether it's heavily affected depends on how extreme the outlier is. Median, not affected by extreme values, requires more effort to determine when compared with a mean. Well, I guess that's, if you're using technology and you already have the data in there, it's not any more effort, but yeah, so it's not really that much effort using technology. And mode can be used with categorical data. Like I said, it's the only one. Might not exist, and it might not be unique. It may include more than one. All right, so I say that we just play around with some homework here, and then we'll call it a day, at least in the sense that, but then I can stick around for questions. And I always, when I go back and edit this video, hopefully this one will work correctly, after I stop lecturing, I kind of even I keep the recordings going, but I always delete whatever is asked afterwards and stuff. So some people might not want to be on the recording, you know, so. And also, students watching this later, I want them to know kind of where the video really ends. The rest of it, they might, well, no, I sat through the rest of that. I really didn't need to, you know, whatever. So, I'll cut it off after. I won't stop the recording, but I'll edit it later. All right, so we got 6 problems in here. Oh, obviously, I want to pick something that's got a little bit of everything. Oh, crud, we haven't done z-scores yet. This is a combined homework. Darn it. I guess I could do part of this and then come back and do the rest later. I don't want to, it's too late now to move into the next section. It's a combined homework, so I should have been thinking I could have waited. Maybe the smart play was to wait till after 3-2. So yeah, it is. It's combined together. But I'm happy to just pluck out the mean, median, and mode for now. You know, because I promised you I would show you how to do it also on the calculator. It can be done in Excel also, but I don't know if mode can or not. But so I guess we'll just do part of these problems and come back and obviously we'll have to redo the mean, median, and mode stuff. Let me just kind of scroll through here and see if they all have that. Okay, well, we don't know the shape part yet, but we can do some of this now. Yeah, we haven't done variant, so I can do 4 and 5. 1 would be good for calculator. Number 1 would be good for calculator purposes because it's a small data set. Now you can look at this. Mode, yeah, you don't really get from the calculator. I don't know if Excel does mode. Definitely does mean and median. So you look at those numbers. Clearly no mode there. Let me see. I believe the command is average. Yes, average. And like I said, I'll promise we'll do this in the calculator also. And let's see if median will come up. Yeah. A1. Of course, this one, you probably could have done it way quicker than I just did by typing that in there because there's only 5 numbers, but it's got to be 3. Yeah, 1, 2, 3, 4. It's 1, 2, 3, 4, 6 if you sort it, and then 3 would be in the middle. So I'll answer that real quick just to get the check mark and then finish the rest of this later. The mean was 3.2. Median is 3. Mode is, okay, no solution. Sometimes, okay, yeah, I didn't know if it happens, if it wanted us to type in anything, but there it is, no solution to the mode. Yeah, the other two can't be no solution, only this one can. All right, so calculator time. If you're interested in this, I'll do this kind of quick because I can always go back over it later. But all righty, so well, you can always go back and watch this part of the recording if you want to too. That'll be a good way to do it because you fast forward and you know it's going to be toward the end. We go to get first thing you do is get your data in the list, stat, and use this edit. Now, if you've got stuff in your list like this, you can go up. Kind of weird how this works. I like the way this red shows up on the calculator. You go up and you hit clear right there below it. But see, you hit clear, it looks like nothing happened, right? Well, watch when I move the cursor. That is so weird to me. I wish it would just clear that list when you hit clear. But as soon as you move the cursor, that's when it goes away. That is odd to me. Now the numbers, they don't have to go in order. Excel takes, for, even for the median, I mean, Excel also does it, but the calculator will take it and sort it. They don't have to be sorted for the average. 6, 3, 1, 4, 2. So I'm going to put them in that same order. 6, 3, 1, 4, 2. Now to get out of that, I go second, quit. And then we're going to use a command right here below, over to the right, bottom right there below, in the stat menu. We're going to go stat, calc, the first one bar stats. Okay, now when you start seeing some of this stuff, you're going to, okay, I'll tell you what I mean here in a second. Different versions of these calculators are going to display a little bit differently. This one's a little fancy. If you're using like an 83, that's okay. I'll just tell you what's the differences are going to be here and things like that. It's not like you need to go out and get one of these. Yours will just show one var stats blinking, and what it won't show this. It just show one var stats, and as long as your data is in L1, you can just hit enter and put nothing in there. It's defaulted to L1, but if your data was in a different column, you would have to bring up the different column, which you can do by these blue things down here. Second blue, second 2 gives you L2. It's hard to see that, but I think that can stay. That might need to either be 1 or maybe nothing can go there. I don't know. We'll see if that. Okay, so there's one command in here where that needs to be a 1, but this isn't it. So if it's blank, if yours shows this, if it doesn't, so you just hit enter. If you've got like an 83 that doesn't show all this fancy stuff, just hit enter, and you should end up with this same result right here. The mean's on top, and to get the median, you got to scroll down a little bit. There's no mode on this. The median is the MED, 3. So there you go. We can deal with this again in the calculator. I'll be happy to help you individually if you're going to do it, if you want to do it this way. But let me go ahead and move on so we can get it wrapped up here. And then, like I said, we'll come back to this section to do those other problems next week. But I did see a couple of them in there that did not look like they didn't involve. Oh, maybe there's like, well, that's got 8 parts remaining. Holy cow! It's this one, I guess. Oh, these are like conceptual questions. We can answer these real quick. I thought I saw 2 of them. That's okay. Looks like there's really no more calculations that we can do until we learn that other stuff. So this isn't a download data. Oh, we got something over here. Let me see what popped up in the chat here. Oh, somebody posting up. Okay, I'm gonna look at that a little bit later here. Excel shows you how to do. Okay, that's good. Thanks. I figured mode was probably a command, but that data set was so easy. I didn't even need the mode. So yeah, that's a nice link there. So if somebody wants to take a picture of that, I think I'm going to take a picture of this myself because it's probably going to go away after the chat's over. Beautiful. All right, so there's just 2 different groups, 2 different medians, no different kind of calculations. We're just looking to see what's the right conceptual answer. Half the salaries of the printer reader are smaller than 80 print reader. No, that's not right because that's for the digital reader. Now the answer C is not right, but I just want to mention that it is possible that the mean and the median can be the same value. The average could also work out to be that way, but that's not an answer that's guaranteed from that result. In other words, it's got to be D for the print readers because that median's 91,083. half of that would be smaller than that. Okay, so yeah, so the mean and the median can absolutely be the same answer. Ta-da! Let's see. Another median question. So they're trying to trick us there with part C. There, part C is asking as if it would have said mode. But that's not even enough to tell you from this anyway. But the most common value would be the mode. But that's not right. So half of which one? Let's see. Digital readers. That's correct. Yeah, so they just used the wrong number with the wrong one for answer B. So it's answer A. Choice A, I mean. Okay, we'll do this one real quick, and I think we'll wrap it up for tonight. Like I said, I'll still stick around, but okay, median. There you go. There's the mean. So this one, the mean's significantly higher than the median. Now this is kind of interesting. Because if you were shopping, like I say, if you were shopping for home prices, let me sort of mention that as that usually doesn't happen too often, this kind of situation. Because generally, if you're in a certain kind of area, region, neighborhood, whatever you want to call it, the homes are kind of sort of all the same. You know, some are more expensive than others. But this doesn't tell you how many homes there were. But what I'm just telling you, what's affecting this is you've got some high dollar homes in that neighborhood, really high dollar, to bring that average up while the median's still 220. So this is where if you're looking at this, you know, where the median could be helpful if you were shopping for homes and you go, and if you only looked at the average, and you said, the average sales price is 282. That seems a little high. But if you look at the median, that's telling you the middle's at 220. Because if you're just, you know, it's just, you wouldn't necessarily be affected by somebody that has a $2 million home there or something like that. That's not how all the homes are. In other words, they're not all super high value. So that the 220 median gives you really a better measure of what the costs are for throughout the area. So that's where the median can kind of help you. We haven't talked about part C, the shape, yet. So we can come back to this one next week, but we can at least knock this one out real quick. So the median is 220, so half would be smaller than or equal to 220. Continue. And the mean's 280. Yeah, so that's this one, C. The mean is the arithmetic average. The average is 282.6. Beautiful. And we don't know part C yet, but obviously we can get back to part C pretty quickly next time just by doing those part 2. We're going to learn, you know, which one determines if median's bigger than mean or mean is less than median. That's going to give you the answer to that one, but that's in the next section. Or yeah, so all right, well, that's going to conclude the show here for this evening. So now I'm just going to step out just for not a 10-minute break, but I'll be back in a couple of minutes. So that way, if anybody wants to stick around and ask anything, but if you don't have any specific questions, or feel free to close yourself out and enjoy the rest of your week. And we'll see you next Monday. But